Okay, so this is 5.1, starting chapter 5, which is going to be graphing trig functions. So we're going to basically take the unit circle that we've done and we're going to put it onto a graph. So we're going to take first sine and we're going to use all of the different sines that we've found and put them into a function. So we aren't thinking so much of triangles anymore, but we're thinking of values at different angles. So we're going to be talking about the sine of all those degrees and radians angles, although it's mostly going to be in radians moving forward. And the sine, or the value of sine at that particular angle. And we can graph that. And the thing about a circle and the thing about these functions is that they will repeat over and over again, because if you keep going around and finding more and more coterminal angles on a circle, you're going to keep getting the same sines over and over again. So we're going to start by filling out this chart. We can use the unit circle to help us, but hopefully these will start getting pretty comfortable in our head, because we're going to need to start memorizing them moving forward. I'm not going to do the decimal value except one time, because it's just going to help us fill in this graph. I prefer to have you do these as their exact value, so with the square root symbols. So if we start up here, the key is that you are thinking about this as y being an output, and that's going to be your coordinate when sine of a particular angle. So this is your angle, you know, in this case in radians. So look at, these are all angle measurements, right? Pi over 6, pi over 4, pi over 3. So when the angle is pi over 6, what is the sine of that angle? That's what our y value is. Okay, so we're just only talking about sine in this first section, and we'll do the sine of all of these ratios going around the whole unit circle. So sine of 0 is 0. Sine of 1/6 is 1/2. Sine of pi over 2 is root 2 over 2. Sine of pi over 3, or 60 degrees, is root 3 over 2. And then sine of pi over 2, when we get up to 90, is 1. So I'm going to just go ahead and just insert the decimal values, just because they're going to help us with our graph. This is about 0.5, right? This is about 0.71. This is about 0.87. So I want to graph these first few points down here on our little graph so that we can see what's happening with this function. All right, the sine of 0 is 0. That means when x, is 0, these are all our input values. When x is 0, our output, or the sine of x, is also 0. So it starts at the origin. Okay, the sine function starts at the origin when it is in its parent function form. Then when we get to pi over 2, the sine function is at 1. So it's way up here. Okay, so we're going to just graph these points that are given to us on the graph here and see what happens. All right, so we've got 0 through pi over 2 equaling 1. Then we keep going around our circle. 2 pi over 3, sine of that is root 3 over 2. Then 3 pi over 4 is root 2 over 2. 5 pi over 6 is 1/2. When we get to pi, sine of pi is 0. So then we can plot that point here. Notice what has happened on our graph. It went up and then it came back down. And that's kind of what's happening on your circle, right? If you trace the circle, it goes up, right? The sine goes up and then it comes back down to 0. So it starts at 0, goes up to 1, and goes back down to 0. So then what do you think is going to happen? If you keep tracing your circle, you're going to go into a negative. Remember, sine is negative in quadrants 3 and 4. We're going to see this happen also as we continue to put in our values of the sine function. All right, sine of 7 pi over 6 is negative 1/2. Sine of 5 pi over 4 is negative root 2 over 2. Negative root 3 over 2. And then we get to our 270, or negative, or 3 pi over 2, and the sine of 3 pi over 2 is negative 1, so we can graph that. Now look where we are, way below the axis down at -1. Keep going. 5 pi over 3. So negative root 3 over 2. 7 pi over 4, negative root 2 over 2. 11 pi over 6 is -1/2. And then the sine of 2 pi is back to 0. So this is the key. These 1, 2, 3, 4, 5 points represent what we call one period, because what's going to happen if we start going around the circle again? So if we start getting coterminal angles and we add 2 pi to all of these, right? If we just add 2 pi to each one of these and keep going, we're just going to get this same shape over and over again, because when we find coterminal angles, the sign is the same for all of them. So once we have these points, we can connect them, and they make a squiggle like this. They keep going. So 5 pi over 2, if you were going to guess where it would go, it would make sense that it would be up here. So we can sort of keep going. We can make the shape. It also continues in a negative direction because we can have negative coterminal angles. So this is what the sine curve looks like. The important things about the sine curve is that it will have 5 critical points. And what it looks like is this, what we just saw. So the shape of sine is that it starts, so it always starts at a mid along what we'll call the midline, and we'll talk about this later. Then it goes up to a max, back down to the mid, way down to the min, and back to the mid. So mid, you could say mid max or mid up. Maybe we'll say up instead of all these M's. Let's call this this. Okay, so it goes up, it comes back, hits that midpoint again, comes back to that midpoint. This is called one full period, because at this point, when we get to this ending midpoint, we've gone mid up, mid down, mid, it's going to start over again. So one period is how long it takes for the function to start repeating again. So for sine, the period is equal to 2 pi, because we started here at 0 and we went all the way to 2 pi before our function started to repeat again. So before we got repeat values and we went up again. So it's the length of one cycle is called the period. So sine has a period of 2 pi, and it has 5 critical points that start at the midpoint and then go up, mid, down, mid. So in terms of transformations from the parent function, if our parent function is this, I'm going to sort of zoom in on this real fast and highlight it. So if our parent function is this here, this is our parent function of the sine. Changing any of these pieces, A, B, C, or D, are going to change the shape of our graph. So just like we used to see this with quadratics, with linear functions, with exponentials, with rationals, any kind of function, when we change different pieces of it, it moves the function in different ways, changes the shape, changes the shift, et cetera, et cetera. Well, the same thing is true with sine and cosine and tangent and all of the trig functions. So A, this A value in front right here, A will change the amplitude, and that is the height of the function, okay? So A will stretch or shrink, right? Our curves. So if this is our parent function, this black one, changing A could stretch the function like this and make it go higher, or shrink the function and make it go lower, like less high. Okay, B, so this value here, B will change the period, which we talked about. which is going to change the length of time it takes for the function to repeat. So it's either going to get longer, it's going to stretch it horizontally. So if I clarify here, this is a vertical. The amplitude is a vertical stretch and shrink. This pulls it up or down, taller or shorter, and then B will stretch it wider, changing the period wider or pushing the period together smaller. So you could have, if this was our gray was our parent function, this could be our period change, right? Or sometimes it can even get smaller. So it might go something like, this, where the period changes far more quickly because you have all those little, it starts repeating much faster. So that's what B does, is it changes the period and causes a horizontal stretch. C is called a phase shift, and it's going to determine where our function sort of starts, but it's going to shift the function horizontally. And we'll talk about how to do that in more depth later. Finally, D is going to cause a vertical shift. It will tell us our midline of our function, or of the graph. Okay, so if D is positive, our midline will shift up. If D is negative, our midline will shift down. So today we're just going to talk about two of these. We're just going to do the amplitude and the period. We'll talk about the first two here today, and then we'll get into more depth later. Okay. So now that we've done sine, let's briefly go through cosine, because they're the same ideas, they just shift slightly. Now with cosine, we are doing the same thing that we just did with sine, where we're going to look at the unit circle, and we're going to look at y is going to be our output. That's going to be our value when we have a particular angle. So again, we have all the angles up here, and then we are going to find the cosine of each of those angles. So we're going to use our unit circle. We can fill this in. I'll put the decimal again for the first couple, but then we will graph down here in the bottom. We'll graph the cosine function and sort of look at how it's a little bit slightly different than sine, but their transformations are the same. So that's why we do these together. They look slightly different in how they start and how they squiggle, but their transformations are the same. So we're going to kind of do them together. So if we start and we're looking at the cosine of each of these angles, the cosine of 0 is 1. Cosine of pi over 6 is root 3 over 2. So again, if I'm using my unit circle, I'm just looking at my x values for each of these. So notice if we bring these down to our graph, cosine of 0 is 1. The cosine function does not start at the origin. It starts at 0, 1. And then pi over 2 is 0. So it's gone down here to pi over 2. If we keep going, 2 pi over 3, cosine is negative 1/2. Because think about your circle. Negative root 2 over 2. Now we're over in the second quadrant. Negative root 3 over 2. And then cosine of pi is negative 1. And now it dips down to its min. You can kind of see the pattern, I think, without even filling in. You can probably see what's going to happen next because it is symmetric in this way. But let's finish filling out. We've got root 3 over 2, 3 over 2, negative root 2 over 2, negative 1/2, and then cosine of 3 pi over 2 is 0. So we're back up here at our mid. And then if we finish up and go back to 2 pi, 1/2, root 2 over 2, and root 3 over 2. So then back to full circle, all the way back to 2 pi, cosine of 2 pi is 1. So now we're all the way back up here. So cosine looks like this, and it follows a pattern of up, down, well, let's not call it down, up, mid, down, mid, up. And then you can figure out where it's going to go next, right? It's going to go back down to this mid. It's going to go all the way back down to the low. And it's doing this on the other side too. So it does not stop just at that curve, but it keeps going. So that's the general idea of cosine. Here's what we need. So cosine also has 5 critical points, just like sine. They just go in a little bit of a different order as we graph. So cosine goes from max to mid, we'll call this up, mid, down, mid, oop, and then up. Okay, so, and again, it's going in a continuous, like up, down, up, mid, down, mid, up, mid, down. So it just keeps going. If we look at our graph, if we started here at 0 and we get to where we're going to start repeating again, the period of cosine is also 2 pi. So one period before it starts repeating itself is 2 pi. So the cosine and sine have the same period before they start repeating, okay? And they both have 5 critical points. They just take a slightly different shape as they squiggle through their values. Okay, same deal. So just like we saw with sine, cosine, this is the parent function. So we have y equals a times cosine of b times x minus c plus d. A will change the amplitude. So a is the amplitude, and that is again the height of the function. So this is a vertical stretch or shrink. It'll make it taller or smaller. Okay. If gray is our parent function, this would be an example of a stretch or a shrink. Okay, in this case, it's stretching. The amplitude has gotten taller than when it was just going through 1. Okay, B will change the period, so how quickly it repeats. So in this case, if our gray function was our initial, and then this is our changed B, notice that it's horizontally stretched. Our period has gotten a lot longer. It's taking this function longer to repeat. So it is a horizontal stretch, shrink. And it's how long it takes the function to repeat. Okay, C is a phase shift. It will change where we start our graph. So it's technically a shift left or right. It's a horizontal shift. And it'll change sort of where we start graphing our graph. But again, we're going to talk about this more in depth later. And then D is a vertical shift. It's a change in the midline. So this will go up or down. All right, let's do some practice. So we're going to talk about identifying the amplitude and the period from both a graphed function and then a not graphed function. So if we can either see it from the graph or if we can see it from the function, the parent function that's been transformed. So let's get these little notes down. The first thing to know, and we're going to talk more about this later, but both of these trig functions have what's called a midline, and it's basically an imaginary line that cuts them in half. So it's halfway between the maximum point here and the minimum point here on the function. So the midline in the parent function without any transformations is at 0. Okay, for both sine and cosine, have a midline at 0. The amplitude of the function is the height of the function from the midline. So how tall is the function from the midline to its highest point and also to its lowest point? It will always be the same. So if it's 1 unit to the highest point, it's also going to be 1 unit to the lowest point, and we call that the amplitude. So the height of the function from the midline. So in this case, the parent function, the amplitude of the parent function is 1 for both of these. So from here to the midline is 1, from here to the midline is 1. So for sine and cosine, their amplitude of the parent, just their regular graph with no transformations, is 1. So in the examples above, the amplitude is 1. In a given trig function, when we're looking at it, the amplitude is found by looking at A, so whatever that value is in front, and taking its absolute value. So we ignore the negative sign if there is one, and we only take the absolute value, and that tells us the amplitude or the height of our function. If A is less than 0, so if we have a negative sign, it will be a reflection in the x-axis. So it will just flip. It'll flip the graph vertically, up and down. Okay, and then the period, like we talked about, is the length of one cycle before values start repeating. And we looked at this in our initial graphs, but like if we look at cosine and we're starting right here, we can see that at 2 pi is where we get a repeat value. So our period is from 0 to 2 pi. And so in the case of both sine and cosine, because sine we start at 0, when we get back to 0 and start repeating, that happens at 2 pi. So the period is 2 pi. To find the period, if you are given an algebraic function rather than looking at a graph and looking for repeats, we find the period by looking at the b value and taking 2 pi and dividing it by whatever b is. That'll tell us the period of our function. So you usually want to find b exactly, but like some little helpful hints are that when b is greater than 1, so when your b value, whatever is sort of that coefficient of your x, if it is greater than 1, you will have a shrink in your period. So it'll be closer together. So it'll be like that. And if b is between 0 and 1, so if it's a fraction or if it's a decimal that's between 0 and 1, it will stretch your function left to right, like horizontally, meaning it will be like a wider period, like that. All right, so let's do a couple examples. These first two are without a graph. So we look at the function, we see what's different from the parent function, and then we can identify. These ones we're just going to talk about amplitude and period. We're not going to talk about phase shift and all that other stuff right now. So if we look at y equals 3 times the sine of x, the first thing we see is, remember our parent function is just y equals, let's put this here, y equals a times times b x minus c plus d. And the only two that we're using right now that we're going to be talking about are going to be this amplitude and period. So these are the two we're going to talk about right now. All right, so if we're looking for amplitude on this example 1, it says identify the amplitude and the period. So amplitude is here. It's the absolute value of 3, which is 3, meaning the height of this function from its midline is going to be 3 units. The period, if we look at b, that's always the coefficient of x. So here the coefficient of x is 1. And we know that the period is equal to 2 pi. So if b is 1, our period is 2 pi over 1. So the period is still 2 pi. We have no change in the period from the parent function. We just have a vertical stretch because it's getting taller. Now the amplitude is 3. Okay, number 2. Example 2, we're looking at amplitude. I'm going to do this in red. which is the absolute value of the coefficient of the function. So the absolute value of negative 1/2 is 1/2. That means this function is 1/2 a unit tall from its midline to its up, and then from the midline to its down. So the amplitude is 1/2, and then the period is going to be reflective of that value there, of that b, coefficient of x. Period is 2 pi over b, and in this case our b is 4. Simplify that, 2 and 4, pi over 2. So the period is pi over 2. It is shorter than it was from our parent function, so it's going to be repeating more quickly because we have a shorter period. All right, let's look at a graph and determine this. First, determine the amplitude. So here's our midline. So the amplitude is the height from the midline to a high point. So in this case, or a low point, and it's always the absolute value. So from the midline, we're going up 3 or down 3, meaning the amplitude of this function is 3. And the period tells us how long it takes for us to start or to restart. So if we look here, here's our 0 intercept at -3. We went down, we're down, right? Mid, up, mid, down. We are repeating again here. This has taken us one period to start getting new values. So in this case, if I erase where I drew that, our period is just 1 pi before it starts to repeat. All right, example 4. Determine the amplitude and period between these two. So it wants us to graph, and it wants us to find the amplitude and the period. So if we are going to use what we know, we can graph amplitude and period. So let's start by identifying the amplitude and period just by looking at this function. So we know that the amplitude is going to be this value here. So 2 is our amplitude. And we know that the period is going to be 2 pi over b. And in this case, the coefficient of x is 1, so 2 pi over 1. Now, to graph the period, we know that it's going to take from here to here for us to get to restarting. We also know that sine starts at 0 and it ends again at 0. So now we're going to use our shape of our squiggle for sine. We know that sine starts at 0, it goes up to the first point, and in this case our high is going to be our amplitude from our midline is going to be 2. Then it goes back to our midline, and then it goes down to the other end of the amplitude. So we have a squiggle like this, and this keeps going. It wants us to go on the other side. So in this case, we're going to just sort of reflect this so that we have the same shape. So we're at a middle. We're going to go down to our other amplitude, back to our middle, up to our high, back to our middle. So this is the other part. So once you've done it once, you can just kind of keep repeating, and this side is going to go down again. So our period was 2 pi. We just drew 2 periods because we went 1 from here to here, and then another from here to here. Okay. I'm going to just, instead of talking through all of these, I'm just going to put up the answers because I think it's going to just get so long and boring. But you can check your answers if you're doing your notes. And if you have questions, of course, ask. Okay, I'm going to talk through this one real fast. So we know our amplitude is 1 for number 5. Our sine function, actually, I don't know that I recorded this. So here's 1 and 2, 3 and 4. And then I'm going to graph 5 and 6 because these don't give you the graph. You have to draw your own graph. So sine starts at 0. And we know the period is only pi. So it's going to end here. In between, remember we always have 5 critical points. So we're going to plot our up, mid, down, mid to our amplitude, which is still 1. So this is our up, this is our mid, this is our down. So the period is much shorter here. And since it wants us to go from -2 pi to 2 pi, we're going to keep repeating this more. So then we just continue with our pattern. Up, mid, down, mid, up. Follow those through. If we just mirror it on the other side, we've got our down, mid, up, mid, down, mid, up, mid, down. And then we can just sort of curve those through. And there is that graph from negative 2 pi to 2 pi. Okay, if you do not have the b in front of x, it is important to factor it out. And we'll do this more as we talk about the phase shift. But rather than writing this as x over 2, I'm going to write this as 1/2 x, so that I can very clearly see that my b equals 1/2. So then my period is 2 pi over 1/2, copy dot flop, copy dot flop. My period is going to be 4 pi. So watch what happens here. When I go to graph this, we know that cosine starts at the top, right, at the up, not at the down. So, but the period of this is longer, and so we need to talk a little bit more about this. But cosine, if we're going to make this 4 pi long, we have to start, if we're going to take this whole thing, actually, let me do this in a different color. We have to start from negative 2 pi because that's the only way we're going to get a full period in, right? From negative 2 pi to 2 pi is 4 pi. So we're going to start with our cosine value and our amplitude of 3. Cosine starts up and it ends up at 2 pi, right? We need 5 critical points, meaning we need to take this 4 pi and we need to divide it by 4 so that we can see where we're going to stop. So if we divide 4 pi over 4, we get pi. So every pi is where we're going to have a critical point. So you divide the period by 4 to figure out where you plot those critical points. So if we're at negative 2 pi and we go pi units toward the rest of our period, and remember cosine goes up, mid, down. I should erase that line because that's actually where my point's going to go. Our down is going to be at the bottom of our amplitude, so down here at negative 3, and then another pi over for our 4th critical point, and ending back with that 5th critical point. So notice that the period of this changed how we had to draw our function. And I should have put arrows at the ends of all of these because these keep going forever. Okay, this one helps you a little bit because they give you the graph divided up. Amplitude is 6, period is 2 pi over 2, which is just, so we're going to set up our sine function. We know the period is pi, so we can do one rotation. Sine starts here, and it's going to end here because that's our period. So if we find 5 critical points in between, we would do pi over 4. And every pi over 4 is where we're going to have a critical point. So here, 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 right? That's divided it up by 4. It's nice because this one has done it for you, but that's not always going to be how it is. As we get better, we're going to be able to do this ourselves. So sine starts at 0. It goes up to the amplitude, and in this case, our amplitude is 6. Then it goes back to the mid. Then it goes down to the amplitude on the other end. Mid, if we keep going, we can just keep doing more and more of this. We're going up, mid, down, mid, forever. I'm going to stop there. Connect our points in our nice little curve. Add our arrows to the end. Number 8, negative cosine of 4x. So this is going to involve a flip because we have a negative sign. Did I miss a negative sign back there? No, I don't think so. Okay. So our amplitude is 1 because this is an imaginary negative 1. Amplitude is 1. Period is 2 pi over 4, which would give us pi over 2. That means cosine is going to start with up. Our amplitude is 1. And it is flipped. So because of this negative sign, rather than starting at positive 1, we're going to start at negative 1. So here is our starting point, and it will end here, right? So because it's this reflection, although it kind of ends up all looking the same. Okay, if we divide pi over 2 by 4, so copy, dot, flop, every pi over 8 is where we're going to have critical points. And again, this one has done it for you. It's divided into 5 little hashes. So cosine, because it's flipped, it's going to go low, mid, up, mid, down. And then we can keep going up, mid, up, mid, down. And then we can just connect with our nice little curve. Good. So the period on this one, I kind of worked the math already, is 3 pi over 4, meaning sine always, starts at 0. And then it goes one full period to 3 pi over 4. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4 is right here. But we need to adjust the middle because we need 5 critical points. So we need 3 things in between these start and end points. So if we sort of divide this into fourths, we'd have one here, here, and here. So let's kind of sketch where we think those are going to end up. So we start with our mid, we go high to our amplitude, which is going to be like here, back to our mid, to our low here, which is our amplitude. So this one was not quite perfect in terms of our placement, but if you get the start and the end, and then you divide in half, and then each of those in half, then you can find your 4 points. So then this one, cosine, we're going to start here. Remember, cosine starts at 2. I mean, it starts at 0, 2, right wherever it starts at our high point, and it will end at 3 pi over 2. This isn't divided up exactly right either. So if we go to the midpoint here, this is halfway between those two. So then we have to go halfway and halfway. So then we can plot our the rest of our 5 critical points. Cosine starts at up, mid, down, mid, up, and then it keeps going. So up, then we back to mid, and again, if we keep going out, we're going to kind of keep going sort of the same distance, which is like kind of like that, mid, down, mid, and then connect. Okay, this one we've got a period of 4 pi, so we're going to start way down here at 2 pi. This is cosine, which starts here at our high, and it's going to end 4 pi later back at our high. So let's divide this by 4. So 4 pi is going to have something happening at every pi units. So cosine goes up, mid, down to our other amplitude, mid, back to our other amplitude. So this is a very wide function. Okay, so this is going to be tricky to draw because they didn't give us a great graph, and that's okay because sometimes that happens. So in this case, this is cosine. Also note this, that it's negative. So rather than starting at our positive amplitude, we'll start our negative amplitude. And our period only goes to pi over 2. So we have to get this whole thing fit in between these two for one full rotation. So if we start at in this case, we'll start at our low because it's reflected. We're going to be at negative 3 halves, which is about here. And we are going to end at our pi over 2, which is here. So we're going to have a little points, critical points at those 3 places in between. So cosine, remember, goes, in this case, down, mid, up, mid, down. And then it's just going to keep doing that forever. It's a very shrunken period if we kind of go the other way. Mid, up, mid, down. This kind of keeps going like this forever. Oops, that shouldn't have gone so low. Ugh, let's make that correct because it cannot go that low. Just keeps going like that. Something. Okay. Oh yeah, period. Put that over here. Pi over 2. Okay, the period on this one's going to be a little bit tricky to draw because, again, our graph isn't super nicely divided up. So when we do our period, 2 pi over b, to our copy dot flop, the period is 4 pi over 3. And this is sine. So sine is going to start here, at 0, right at the origin. And then it's going to go to 4 pi over 3, which is kind of like a little bit bigger than pi, right? Because it's like 1 and 1/3 pi. So let's maybe do it like, I don't know. Let's call it, it's 3 pi over 2. I feel like it might be like here. I don't know. We'll kind of guess. This would be our end point. And then what we're going to do is just divide sort of in half and then in half again. And we can use those hashes to kind of guide our sign. Now notice also that this is negative. So rather than going up, mid, down, we're going to go down, mid, up. So here we'll go down to our amplitude, kind of guessing, back to our mid, up to our amplitude, and then back to our center. I'm going to erase my little hashes because they're just making it look messy, but that helped me kind of plot. And then this would continue going in either direction for more periods than just this. So something like that. I'm going to go ahead and skip this because I don't want to do another fraction one where we can't see it. And then let's go ahead and just graph number 10. Okay, amplitude is 4, period is pi. This is a sine function. So it starts here at the origin and it's going to go pi rotations before it repeats. So we're going to have things occurring at every sort of grid mark on our grid. So this is not a flip, so we're going to start with 0, 0, our mid. We're going to go up to our amplitude. So up, back to mid, down, mid. And then we can keep going if we want. Up, mid, down, mid, and we can also go in the other direction. So we'd be at here, 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 etc. So whatever, this is kind of going like this. That's our sine function here. And that's that.